if anyone comes in afterwards, we'll go ahead and get this QR code posted at the end so you can get their attendance marked down. Welcome. This is the second call out. I guess it's going to be the same content, but this is the call out for the Autonomous Robotics Club of Purdue. We're going to be going over sort of how we operate as a club in general. I'm going to get to know a little bit of the team so far, some about our ongoing projects, and figure out how you can sort of get involved if this seems like something that might be up your alley. So kind of covering that, just you can see what I've just mentioned in the agenda. We're going to do some introductions of our leadership team, talk a little bit about our club purpose, how we operate as a whole. That kind of touches into the meeting schedule as well. We're going to talk about how COVID-19 has sort of shifted how we operate and what the requirements for that look like. Then we'll discuss some of the ongoing projects we have. We'll also mention the steps for starting a new project if there's something you're interested in. And then we'll talk about onboarding for new members and next steps for sort of everyone on the team. So to start, some introductions. My name is Harrison McCarty. I am a third year in computer science, and I am the president of the club this year. I guess I'll just go ahead and pass it off. Let's go, Raghava.
Hello, my name is Raghava. I'm a sophomore in computer engineering, and I'm the software lead of the Robot Arm project.
All right, hello. I am Sarah Swanland. I'm a sophomore in mechanical engineering, and I'm the hardware lead of the Robot Arm project.
Hello, my name is Alina. I'm a sophomore in mechanical engineering, and I'm the project lead for Wizard Chess.
Hello, my name is James. I'm a senior in mechanical engineering, and I'm the project manager for Rocket League.
Nice. Now let's talk about how we sort of operate as a club. So our more official mission statement is that the Autonomous Robotics Club of Purdue is their mission is to openly explore challenging problems in the field of autonomous robotic systems. And through ARC, students of any background can collaborate with an active community to share knowledge. Boiling that down, I think the key words you can take away from that is that we are a community. So you might be familiar with other robotics clubs at Purdue who have sort of shifted mission statements that might be more in line with a competition or maybe focused on creating some sort of financial return or working directly with some companies. The big mission for us is that we're looking to allow any student with a passion for robotics to come into the club and explore those interests. So we don't really have any strict requirements for what can be a project. We don't try to limit students really in many ways. We just try to ensure that they're able to explore that passion for robotics and share that with others through the community we've created. And a big part of how we do that is, like I said, allowing sort of a vast diversity of projects. These are going to be what comprise of most of your meetings throughout your time in ARC. So you can see, I sort of outlined the different types of meetings you may experience while being a member of ARC. So project meetings are the biggest one. Like I said, they're going to be hosted on a basis of whatever project you end up becoming a part of. So that'll be something you work out with your project manager, and it'll be better fit to what your schedule is, but they're definitely going to happen a lot more frequently than something like leadership or social events. And these are also led by project managers who were introduced a second ago and will be introduced as new projects come your way. Leadership meetings, so these are hosted weekly. If you were on the club in the past, these used to be our general team meetings and used to be, I believe required. We're kind of shifting direction for those sorts of meetings. Instead of having them required and sort of ensure that every team member must be there, we're going to make these optional for general team members. So if you're interested in exploring more about leadership within ARC, or you want to hear updates about other ongoing projects within ARC, then this is something that you can definitely attend and get more information through. And it's just another outlet for you to get involved with the community. And then lastly, we have social events. So these are going to be hosted monthly, if not more, hopefully. That's always a goal we have. And again, these are also optional. It's on you if you don't want to have fun. And they can consist of a variety of technical and non-technical activities. So there's lots of ideas in the works of what these might look like this year. In the past, especially when we were operating more from a remote sense, we would do stuff like Jackbox and other virtual type games over Zoom. But now that we're in person, we might start doing similar social activities. So looking at possibly like movie nights is something that's been discussed. it's also a priority for us that we're also providing resources for you guys to be able to be successful in whatever projects you join. So we're also looking at possibly providing like some tactical social events where we have a very nonchalant sort of workshop that goes over some sort of skill that we find important or useful for any project you may be working on. So the way these meetings get adjusted through COVID is primarily in its scheduling. If you are in a project and you do end up becoming like a project manager, you have to schedule these meetings out 2 weeks in advance. Attendance must be required and masks must be required. Attendance must be tracked. Can't speak today. For virtual meetings, it's a little less strict. As long as you schedule this with me, it should be fine. As like if you're under 2 weeks. But the big one is just for in-person events. You just have to make sure those are around 2 weeks out from your actual deadline, just as another requirement through SAO. All right, so now we're going to start going into some of our active ongoing projects. This isn't going to be a comprehensible list of what might happen throughout the semester. This is just going to give you a sense of what's being carried over from previous semesters and are already ongoing projects that you can hop on board. After we go over these active projects, we'll sort of discuss a little more about what's the process for starting one of these new projects. So I'm going to hand it off to James to talk about Rocket League.
Hello again. So up here, we've got a picture of sort of what our setup looked like from 2 semesters ago. I've got a couple other images and videos I'm going to walk through. But I'm basically just going to try to give you a real quick overview of what this project is and what you could expect if you chose to get involved with it. So if you're familiar with the video game Rocket League, we're basically trying to make that happen in real life with physical RC cars. And if you're unfamiliar with the video game, it's pretty simple. It's just soccer with fast cars. So sort of our end goal, something that I think would be really cool to have done by the end of this year, is to have it set up in such a way that we can drop it in the atrium of a building, like we hand Xbox controllers to random people who walk up and they control 2 cars, physical RC cars, and then we have another 2 cars that are controlled by the computer. And then, you know, in a physical arena with physical balls, physical cars, they basically play soccer right there. And ideally, you know, our autonomous agent that is their opponent would be smart enough to present something of a challenge for them. So there's a couple different systems that go together to make something like this function. And you can see some of them sort of called out in that picture there, but I'll sort of walk through them as we go. So the very first one is sort of our perception system. So this is how we're able to figure out where everything is. AJ is on the perception team. So we've got 4 cameras suspended on those poles there. We're going to be upgrading that to aluminum mounts in the future. So there's some hardware opportunities if any of you are interested there. But basically, we're using technologies like OpenCV, April tags, as well as some sort of color processing so that we can, you know, use our cameras to look at the field and then spit out the location of everything we care about in 3D space. And then ideally that's happening at like 15 hertz or faster. And that's a pretty challenging problem and something we're really going to be pushing this first semester. Then sort of the next system we have is the low-level control. So all of the cars are running standard RC hardware inside of them. So we've got a little box here that is taking controls from the computer and then it's sending it over to the radio transmitter, and then it's getting picked up by the car. And then there's also going to be some code running there that has to do a control loop on the car. So it's going to have something like a PID controller, and that's going to keep the velocity and heading of the car fixed at what we control it to. So that's another way to get involved in the project. Next, we have sort of what I'm calling mid-level software. And this is mostly implemented in Python, also using ROS. But basically, we're given a trajectory for the car to follow. Something along the lines of this is where the ball is, this is where the goal is, this is the velocity we want to hit it at. And it has to plan some sort of spline to get there, and then it has to hold the car accountable to follow that. So you just saw a quick video from our simulator that we have. And then the very last piece is that we need some sort of, you know, higher understanding of the game to tie it all together and generate those trajectories. So we have a machine learning system. Right now it's using PyTorch, which is a Python reinforcement or we're using it for deep reinforcement learning, but it's a machine learning library in Python. This isn't Rocket League, of course. But this is the snake game. So basically the snake tries to eat those red apples. And so that was something that we developed last semester as sort of a stepping stone to make it to Rocket League, because that's a little bit harder. And so that's another big thing that we're going to be pushing this semester. So if you're interested in computer vision, sort of any sort of general control systems, general Python programming, making that stuff more robust, or machine learning, or really any hardware and electrical tasks, this could be a good project for you. Okay, next to Raghava.
Right. So now just want to introduce a little bit more about the robot arm project. So the kind of goal here is we're really trying to answer the question, why don't we have robot arms in our kitchen, folding our clothes? And it really comes down to the fact of the environment. A lot of robots, a lot of you, I don't know, how many, raise your hand if you've seen a robot arm. Awesome, okay, a lot of hands, okay. And I'm assuming those robot arms probably aren't, in your homes or, in offices or something, but more in like factories, moving, large cars around, or doing kind of pre-programmed trajectories. And that realistically, like if we want to have a robot arm in a home environment, it needs to be able to understand its environment and be able to also be robust enough to work in multiple environments. So we're trying to explore this problem, and we're starting off real slow, real easy with, not easy, but from the bigger scale, by having it play chess autonomously. So chess, it's a pretty self-explanatory game, like in terms of like what the robot needs to do next. If the opponent moves a piece, the chess engine will probably be using a chess engine that can compute the next piece, and then being able to pick in place and move the piece. So it's not we're not cooking right off the bat here. So given that that's our goal, we've been working on it for like the last couple of semesters, or since spring of last semester. I do want to take you back to the start of the fall, a year back, when we first started the project. So December of 2020, what we really want to do is really understand the robot arm itself, like the kinematics and the math behind it. And what that really boils down to is the idea of, given that a robot arm really only understands its like an angle value for all of its joints. And if you go and try to pick something up, it's you don't really think about all those numbers, you just kind of do it. And you're interacting in XYZ space. You can kind of relate to that car from you as like some coordinates, but a robot arm still doesn't know that. It only knows 5 angles or 6 angles. So that conversion from those joints to the XYZ called inverse kinematics, and that's one of the ways we were able to have the robot arm here be able to pick and place these boxes. So given that was our first task that semester, it's just we wanted to play Jenga, but didn't really have a Jenga board with us, so just found some boxes and did basic pick and place our first semester. Let that play out there. So yeah. And by the way, that was not on its first try, after maybe like 15, 20 tries. But yeah, so then in the spring, what we wanted to do is start moving towards the game of chess. And we quickly found out as a software team trying to develop this that it's difficult without an actual arm, which was also in development. Also, sorry, I kind of forgot. Sarah also was developing, at the same time, we're also developing our own arm. And Sarah was in charge of developing a 6 degrees of freedom arm. And do you have anything to say?
There is a reason we call it Mr. Janktastic as the official name of this arm. So it's our first try, but we are working on developing multiple different kinds of arms using as many different approaches as people are willing to work on.
I think we had a question in the back, and this also goes just in general. If you have any questions anytime, I think we're pretty comfortable just taking those questions as we go, just so you don't forget them. And same goes for the chat. But I believe we had a question back there.
So what kind of programming you use to program that robot arm?
So the question was what programming languages do we use to program the robot arm? And we mainly use underlying software called ROS, or it's more of like a framework that everything is connected together. And then we use Python and C++. And actually this website, the wiki, if you go to the software docs, you'll learn more of like the kind of fine-grained details of what we use. So yeah, continuing on, we had to also build a simulator just to make it easy for us to test the different scenarios and to just test our software that we were developing on the actual arm, and to make it easier for remote people to also work on the robot arm. And additionally, and this is a video of it, just being able to pick up a chess piece. This is a prototype, just pick and place. This is not autonomous. This is just testing out like the hardware and ensure like grasping it, like the grasping aspect. So that's still like a to-do task. And then lastly, we built a data set specifically Vanita, who's one of our software members, developed, and I think over there. No, I don't know. Is she here?
Yeah, she's right there.
Yeah. Okay. Yeah. So yeah. Okay. I didn't know it's first. Yeah. So she put together 500 piece. Actually, it's I think like 1.5K piece chess piece data set of images and labeling, and we use that to train this neural network here to be able to detect all the chess pieces with a pretty decent accuracy. So we need to be able to do that to be able to move chess pieces. So it gets there's levels and in terms of object detection and moving and picking up the piece, which is another thing called visual servoing. And there are some more of these different components that are also further detailed in the software docs. So this is a little kind of crash course on kind of the history of robot arm and what we're trying to accomplish. Now I'll hand it. I'll also be handing it over now to Rohan, who'll be talking a little bit more about how you can build a simulator of, for example, these environments, such as the robot arm, and also other environments as well. Oh, got a question.
What level of mathematics do I need to know in order to contribute to these projects?
So it depends on what system you're working on. So there's some systems, like I guess I can just click on this. So there's kind of different systems that are more kind of mathematical, like for example, like the visual servoing, and a lot of these have like more prerequisites, but we do provide resources to learn them. And at the same time, things that are more lower level are less mathematical because they like interact directly with the hardware. So it's more of just understanding like the just the underlying system and how to use like syntactically to do things.
And just to tag onto that a little bit, for any of the projects we never have any official requirements for something that you need to have experience in or to have worked with in the past. It's always a case where if you have the passion for whatever it is you're working on, or for robotics as a whole, we're going to try our best to provide you the resources to be able to apply that passion to the actual projects. So no official requirements and knowledge for any of the projects we work on, just a desire to learn.
Cool. And did I answer your question?
Yes.
So now I'll hand it over to Rohan.
So this is kind of an upcoming project idea thing related to the robot arm. So we talked about so some things to remind you from what Raghav just talked about. The robot arm currently is controlled by inverse kinematics, which is a very mathematical approach to controlling the robot arm, but it's also very robust. However, there's a lot of different control theories and methods. There's a whole field dedicated to it. And trying out all of those on the physical robot is impractical and unsafe. So some of these could be inverse kinematics, optimal control, reinforcement learning, which you may have heard of. All of these can be tried, but using them all on the actual robot and hardware is inefficient. Secondly, some approaches like reinforcement learning are going to take a lot of samples to learn. So you said that the video you showed that took like 15 tries to get it right. Reinforcement learning, it's going to learn to move the robot arm. So it's going to take something more like 15 million samples to learn how to do that. So that's again something that obviously we can't do on the real hardware. This is where simulation comes in. So there's these softwares that are used for simulating robots and basically physics engines. Some of these an example of this is Gazebo, which is pretty well known, but there is much more physics accurate softwares called Mujoko, PyBullet, and Brax. Has anyone heard of any of these three, PyBullet in particular? Raise your hand. No? Okay, nothing. So the point here is that these can be used to simulate real robots and actually simulate like how they're going to pick up objects, like the blocks in the previous video. And then you can program like controllers and see how different controllers work out in simulation. So this effort is probably going to be in Brax, which is a simulation software developed by Google. And it doesn't really have that many prerequisites. The main task here is just going to be figuring out how like the robot's arms, what their weights are, what the XYZ coordinates are for the joints and so on, and then re-implementing them in Brax's API. And once that's done, we'll be able to run like different controllers, like I mentioned, especially integrating it with some sort of reinforcement learning interface or library like OpenAI Gym. Now, an additional task here, after we're done re-implementing the robotics arm, is that OpenAI Gym itself is looking to transfer its robotics and like physics environments from a closed source software named Mojoko to something like Brax. This is still in the early stages, but the idea here is that it may be possible for us to eventually contribute to that effort as well, with like members who have worked on simulating our robot arm. And yes, that will give a really good amount of experience with Brax, which could lead to open source commits to a very well known, very popular reinforcement learning library called OpenAI Gym. And again, this project, it may sound complex, but really it doesn't have any prerequisites. The main thing is just like taking measurements and putting them into the Brax API. Any questions on this? And then.
Hello. Okay, my name is Elena. I'm the project manager for Wizards Chess. And this is actually our second semester for the project. And basically what we're doing is taking an idea from like Harry Potter and the Philosopher's Stone when they played the real life chess at the end of the movie and making it into a reality. So what we've done is we're planning on creating 32 chess pieces with each chess piece as like its own robot. And the way it's going to work is we're going to have voice recognition. So you have voice recognition, and the overall controller will take that and create it into like trajectories onto the board and it'll make sure that it can plan each piece to go to the correct spot. So unfortunately, in the spring semester, we were really impacted by COVID, so we only really had a couple weeks of development. but what we were able to do was get the wheels turning. So, coming up this semester, we're gonna, we also developed like the chess algorithm to input commands and calculate it into what spot it needs to go on the board. We're still working on the voice commands, but coming in this fall semester, we're going to be taking that robot, scaling it to create 32 of them, which is going to be a pretty big hardware task if you're interested in that. And then we're also planning on so in the spring semester, we had planned to use RFID tags to label each of the squares so that the robot knows where it's going and where it is. But in the fall, we're planning on switching to computer vision with a camera overhead so that it can detect exactly what piece is where it's going, where it needs to go, and like what inputs are valid. So if any of that sounds interesting to you, just come talk to me. We'd love to have you.
Awesome. Big round of applause for our project managers. So I hope you got a good understanding of the diversity of projects that we take up within ARC. We have projects ranging from pop culture inspiration to making contributions to very well-known libraries within the field of robotics. So we're kind of all over the place, but that's how we like to be. We, again, just like to fuel whatever interest or passion you may have about the field of robotics. So the next obvious question might be, if you want to add to that diversity, how do you start a project? So a few things that we're looking for when individuals come to us in hopes to start a project is that they have a pretty concise mission that they're hoping to achieve. They know what it is that they want to reach at the end of the semester and even maybe further if the project needs to extend so. And then also there's surrounding interest in the project. So if you come to us as a single individual with an idea who's looking to pursue a project, it's a lot less likely that we're looking to hopefully adapt that into our community. We want to see projects that really inspire and excite a lot of other individuals who are part of this community. So a lot of times this looks like a team around 6 to 12 individuals. Any more than that, and you risk possibly overextending yourself and having too much to manage at one time. So we found that range is usually a good area to stick in when going about starting a project. A few questions you might want to ask yourself when you're considering starting a project or you have a few ideas that you need to put together. You want to be looking at how can you describe this in a concise manner. So going into the next few weeks, we're going to be having project pitch sessions where you will be explaining your idea to the leadership team, and we really need a concise answer for what it is you're trying to achieve. That not only helps us understand what it is you're trying to achieve, but that'll help you find future funding and members when you're trying to recruit them, and use that same information to give them an understanding of what it is you're trying to achieve. Some other good questions to ask yourself might be what sort of resources you may be needing. So what's the timeline going to look like? How many semesters may this take to accomplish your overarching mission? How much money might this require to fund a project? Robotics can get expensive very fast. These are all sort of things that we need to be aware of and that you should be thinking about when going into the process of starting a project. And we'll talk a little more in the end what some action items might be if this is something that you're interested in. So specifically for onboarding with newer members, we highly recommend you take a look at the wiki. That's what Raghava showed when demonstrating the robot arm project. This is sort of a resource that we created in the past few months just to give a brief overview of our ongoing projects. We'll also be uploading tutorials here as they come up. So just various resources about how someone might go about learning ROS, or for actually starting a project, we're going to have some resources coming up soon that'll walk you through that process and give a few tips that we found were helpful for us. Project managers will be primarily responsible for guiding students through the process of acquiring the necessary skills. So I mentioned earlier that we have no real expectation for prior experience. Part of how we solve that is once you get incorporated into a team, the project managers are going to be the ones who are guiding you in the direction that you need to go in. So if you were assigned to work within a vision portion or component of a team, then they're going to guide you in their direction to figure out where those resources are. If at any point in time going through that process, you find that the resources don't exist within the team and they could be helpful to exist within the team, definitely let us know. that's sort of an objective for us at a given point in time, is that when resources are demanded by the internal team, that we're producing those and ensuring you guys have those at hand. So a lot of times it may be helpful just to use an external resource, but if there is something that you think could find value in being an internal resource, definitely let us know and we'll get that solved. And then lastly, again, just don't hesitate to reach out for about anything. We're always looking to help anyone out who's interested in getting involved, and don't want anyone to feel left behind if schoolwork catches up with them and then they need to take some time off from the club. So yeah, big key point is the wiki. That's where you're going to figure out a lot of the ongoing information about ongoing projects. And then also just being aware that once you get involved in projects, that's when you'll start actually onboarding for the technical skills. Now, overall action items for the club as a whole. So we're going to look and hope that everyone can join the Discord. That's where that's where mostly our community lives, is within that Discord. If you're interested in joining a project, they're going to be hosting and discussing meetings about onboarding for that specific project. So each ongoing project should have its own category within Discord, and under that there should be an announcements channel. That's where you'll see those meetings scheduled. So if there's a project that's been announced that you're interested in, you're going to want to be watching that announcements channel for that specific project, and they'll be announcing, I think 2 have already been scheduled. They'll be announcing when those onboarding meetings are occurring. So that's how you can get involved further with that specific project. If you are looking to start your own project, where primarily that's going to take place is at the project pitch sessions, which I mentioned earlier. So we'll be scheduling those in the general chat, and you'll just see them come up. They should be scheduled within the next few days. And once that happens, that'll just be essentially a 30-minute to hour-long meeting, where any individual who has an idea for a project can essentially throw it out there, hear what the leaderboard or leadership team has to say, and then we can go from there and determining whether we want to support that throughout the semester. I'll be sending out these slides at the end of the presentation. Oh, question.
I'm just curious, do any of you guys work with the Autonomous Vehicles Club?
So that's a good question. He asked if any of us work with the Autonomous Vehicles Club. I'm assuming you don't mean PAVS, right? Purdue Autonomous Vehicles Association. There are like a couple different autonomous vehicle clubs at Purdue. There's some associated with the like electrical vehicle racing, and probably a few others. Is that what you mean?
If there are multiple, then I only know one.
What I can say is we, at one point in time, were associated with Purdue Association of Autonomous Vehicles or something of the sort.
Purdue Autonomous Vehicle Society.
Purdue Autonomous Vehicle Society. And I think it would be a plan to probably continue that relationship. I know other teams like Robotics are involved, and Purdue Electric Racing. I'm not sure who is in complete involvement. James can talk more about that.
Yeah, the short summary is that there's sort of a big umbrella called Purdue Autonomous Vehicle Society, which we basically started, and we just try to pull together all of these different groups. So there's Purdue Lunabotics, Boiler Robotics, Purdue Electric Racing, Purdue Autonomous Motorsports at Purdue, and then Purdue Autonomous Racing Club. So there's a whole bunch of us, and we're all doing similar things. So we try to pull them all together so we can do, like corporate seminars, so that we can hear from companies, get recruited by them, stuff like that together.
Yeah, like if you were on camp, or if you were here last year, one of the events that James was sort of talking about there was the John Deere event, where we, in collaboration with the other teams, a part of PAVS, hosted an event that essentially gave platform to John Deere to talk about some of the ongoing projects they have within the field of robotics, and was also a good opportunity for some of our students to connect with full-time employees there. Good question, though. Back on the topic of sort of starting a project, I'll be sending out these slides, which will include this sort of information, just about what questions to be asking yourself. The project pitch session is primarily just going to be more of an abstract discussion. So as long as you have sort of a focused mission and you have an idea of where you want the project to head, and you have a few other individuals who are sort of on board with that process with you, that should be enough for now. There will be posting future requirements about like the next steps following that project pitch session that will stem from that meeting. And if you're looking to start that project as well, I'd also recommend in getting those members who would sort of be on board with you, you're advertising that within the general chat. So if you have an idea or if you have a mission that you're sort of thinking of in the moment, make sure you throw that out in the general chat and see if you can get some buzz going just among other team members and seeing if there's other interest within the club in supporting your project. So again, those are sort of the two routes I guess you could take, is joining one of those ongoing projects, starting your own. Beyond that, scan the Boilerlink code. That'll get you actually added to the club, which is just a formality through SAO. And then also be looking out for social events. So I mentioned earlier that we're discussing or have movie nights in the works, which should be fun. And then also follow us on our various social media accounts to stay updated with any other projects and information going on. Now we're going to sort of move to a question time for a general team. So if you have questions about sort of how ARC operates as a whole or about starting a project, this would be good to ask. And then if there are no questions here, or if we answer all these questions, then we'll move to sort of a broken out period where you can ask questions to any of the specific project managers about their projects. So if we have any general questions now.
Do the project leaders like send out the meeting schedules over the Discord?
Yeah, most of that is organized through the Discord. The process would sort of look like this. You would eventually, if you got sponsored as a project, you would create your own category within the Discord, which is where all of your discussions would happen. And you would try to find a meeting time that would work well between all of your team members. And then that approval process would go through me. So you would reach out to me just about what your new meeting schedule would look like or what few meetings you want scheduled. And then I'll send up an APF for that, which is a formality again through SAO. And as soon as that gets approved, then you guys are good to go for any of those events or meetings. Good question. Any other general club questions? Dope. So now we're going to sort of break out into more of a project-based question time. If you also need to head out, this is the time to head out. But we'll be stationing the different project managers in various areas, and you're free to walk up and just ask any questions you may have about their specific project. Overall, though, thank you guys for coming. If you weren't able to get your attendance marked at the beginning, feel free to do that now. And yeah, go ahead and find us wherever we'll be if you have any remaining questions. Thank you, guys.
I don't know if you've ever heard that.
I've heard of him. You know what? He does look like him. Yeah, he should have maybe checked the
Crash Course? Yeah, doesn't he look and sound like John Green? Or am I crazy? Oh my God, right? A little bit. I was like, you don't.
Yeah, there's a resemblance.
Aren't there the two?
Yeah, you don't get this. There's